Right, so in this video I'm going to have a look at the average value of a function. So first thing I'm going to do is just show you where the formula for this comes from. So we have this function here, f of x. It's this red curve here. And we're going to look at this function between a and b, between the closed intervals a, closed interval a and b. So we're including a and b here. So I've divided this curve up into equal sections here, and these sections are, this is where this is if my first x here, x is equal to x0 if you like, is equal to a. This is x1 here, my first 1x, this is x2, and so on, and this is xn minus 1 here, and my b here would be xn. Now, and this is x0 here at a. So what I want to do is find the average, find a formula for the average value, and that just means the average y value, if you like, all the way along here. So maybe around here somewhere, this value over here, I'm not too sure, but it's the average value of all the values along here, along the red line. So I picked 1, 2, 3, 4, 5, 6, 7, 8 values here in this particular case. So I could just pick those 8 y values, add them up and divide by 8. That would give me an approximate average value for the curve between the closed interval a and b. But let's go a little bit further with that. Let's have a look at what we've got here. I've divided the area under the curve here, if you like, into these equal sections here. So each of these sections is we're going to call it delta x. The width is delta x. So delta x. So the width along here is just delta x. So this is delta x as well. So this would be delta x in width, and so on. All of these are just delta x, the same width, all the way along here. So that would mean then really that delta x, the width of each of those segments, delta x, is just going to be equal to b minus a over n. So as a simple example here, if you have if I have another curve here, and let's say this is 1 here and this is 4 here, if I divide that up into 3 sections, so 1, 2, 3 equal sections, each of these widths here would be 4 minus 1 over 3, or just 1 unit in width. So 1 unit, 1 unit, 1 unit here in width. So we are dividing the closed interval a to b into n sections, so it would be b minus a over n. That's what delta x would be. That's what each of these widths would be. So I can just cross multiply here. This is over 1 here, so I could write n is equal to b minus a over delta x. So I just have n here in terms of b, a, and delta x. Now let's have a look then just at the next step. So the average value of the numbers, let's say f of x0, f of x1, f of x2, all the way up to f of n minus 1. So I'm just having a look at, this is x0 here. This value here will be f of x0. This is x1. Just draw it in here. This here would be f of x0. This here would be f of x1. This here would be f of x2, and so on. And I'm going out as far as here, and you'll see why later on. I'm not going to go out as far as xn, I'm just going to go out as far as here. So if I come over here, then this would be f of xn minus 1. Now the average value of those numbers then is just going to be all of these numbers added divided by n. There are n of them. So let me just write that out. So what I'm going to end up with here is f of x0 plus f of x1 plus, and so on, up to f of x n minus 1 divided by n. This is the average value for all of these individual y values. That's just going to be equal to f of x0 plus f of x1 and so on up to f of x n minus 1 all over. Remember, up here we had n is equal to b minus a over delta x. So instead of this n here, I'm going to put in b minus a over delta x. So underneath here I'm going to have b minus a over delta x. Okay, so from here then I can just, I'm dividing by a fraction here, so I can just flip this fraction upside down and multiply. So I end up with delta x multiplied by each one of these individual y values here. And on the bottom then I'll end up with the b minus a. So I'll end up with f of x0 times delta x plus f of x1 times delta x plus all the way out here to f of x n minus 1 times delta x. And this is all over. Remember, I flipped this upside down, multiplied by delta x. I've done that along here. And on the bottom then I'll just end up with b minus a. Okay, so what I can do now is just take the 1 over b minus a out here. So I'm just taking this over here, and I'm going to multiply that by the top line here, which is effectively the same thing. So I just end up with f of x0 times delta x plus f of x1 times delta x plus all the way out here to f of x n minus 1 times delta x. So this line here is the same as this line here. I've just taken the b minus a outside the bracket here on the bottom. Now if you look at this here, each one of these individual terms here is just the area of each of these, would just be the area, approximately the area of each one of these. Really they're trapeziums, I guess. They're nearer trapeziums than rectangles, but this is delta x, and then I'm multiplying by the height here. So it's roughly the area of this, if you like. And the reason we went out here to n minus 1 is because we were multiplying this by this delta x here, so we're finding the area of this, if you like, roughly speaking anyway. So this is what we've ended up with anyway. Now let's just go again. Now as we see here that if we say n goes to infinity, in other words, we have, I think it is 8 sections here. 1, 2, 3, 4, 5, 6, 7 sections actually. But if we take n going to infinity, so we have an infinite number of these sections here, what happens? Well, this part in here just simply becomes, so in other words, I'll just put implies here, f of x0 times delta x plus f of x1 times delta x, and so on. F of x n minus 1 times delta x. All of that there just simply becomes the integral from a to b. The integral from a to b of f of x dx. This really is just the area under the curve, if you like, and we've seen that in previous videos. So this here just becomes the area under the curve between a and b. So this part up here, this part inside these square brackets, is really just as n goes to infinity, it just becomes this thing here. So we just end up then with the average value just simply then becomes 1 over b minus a times the integral from a to b of our function f of x dx. So this is our final formula here, if you like, for the average value. So that's it really. Let me just do a couple of examples to show you how this actually works. So this is the formula we're going to use here. So I'm just going to take a simple function first of all. Let's take f of x, and do this in white I think. So f of x, no, wrong color again. Okay, there we go. F of x is equal to, let's just take x cubed. Now that function will look like, roughly speaking anyway, it'll look something like this. It'll come down along here, it'll flatten out here at 0 and then come down, whoops, let's do that again. So it'll come down along here, flatten out here at the origin, and then go on down here like this. So let's say we take the average value of this function between 2 and 4. So we're going to take the average value between 2 and 4. So let's say, I don't know, 2 is here and 4 is here. So what we're going to do is look at the average value. The average value is going to be somewhere probably around here. This is going to be our average value here. Okay, so let's do it using our formula. So we know that the average value, again I'll do this in white, so the average value is equal to 1 over b minus a, the integral of our function f of x dx between b and a. So in our particular case we want to find the average value between 2 and 4, so it's going to be 1 over 4 minus 2. We're going to integrate between 2 and 4, and our function is x cubed dx. So this is what we've got to do. So this is just simply going to be 1 over 4 minus 2 is 2, and then when we integrate x cubed we get x to the power of 4 over 4, and our limits are 2 and 4. So let's just do that. I'll do that over here, let's say. So we have a half, and then we want to put 4 in here and 2 in here and subtract them. So we're putting 4 in, and that's going to be to the power of 4 over 4, and then we're going to subtract. Now we've got to put 2 in, so we're putting 2 in here, and that's going to be the power of 4 over 4 as well. Okay, so when we do that, then we get a half of 64 minus 4, and that's, when you work that out, you just get 30. So the average value of our function between 2 and 4, this value here, in other words this value over here, will be 30. Okay, so let's do another one, a little bit more detailed, a little bit more complicated, but effectively the same thing. Let's take a function, another function, we'll call it f of x again, and we'll just make it a little bit more complicated. Let's say minus 1 over 250 times, actually let's use t this time rather than x. So I'll just take this out here and we'll use t. So let's say it's a function of time, for example. So we'll take t cubed plus 1 over 10 t squared minus 5 over 8 t plus 50. So we could say this is maybe a velocity and at any time t or something like that. It can be any function like that, and you want to find the average velocity over a particular time period. So let's say we want to find the average value for this function over the closed interval 6 to 25. So what we've got to do here is look at our average value. Our average value is going to be 1 over b minus a, which is 25 minus 6, times the integral of our function between 25 and 6. And our function then is just simply minus 1 over 250 t cubed plus 1 over 10 t squared minus 5 over 8 t plus 50, and this is with respect to t here. So let's do that. So you've just got to integrate this function here. Now That will give us, well, 1 over 25 minus 6 is just 1 over 19. Now let's integrate this function. Okay, so we have a t cubed here. If you integrate t cubed, you're going to get t over 4. So that's going to be t over 4 is going to be on the top. We have this minus here as well. I'll just put that there. Now it's t to the power of 4 over 4. And we have this 250 on the bottom as well. So I'll multiply the 4 by the 250. So that will just simply give me 1,000 on the bottom. Okay, next one then is a plus. We have a t squared here, so that's going to be t cubed over 3. But we have a 10 on the bottom here, so 3 tens, 30. We have a minus. This is going to be t to the power of 1, so when we integrate it, it's going to be t squared. So there's a 5 on the top, and it's going to be t squared. And the 2 on the bottom, so it's going to be 2 divided by 2, so 2 times 8, 16. And here we have a 50. If you integrate 50, you get 50t. So that's our integral done, and we want to do that between 6 and 25. So the next part is just kind of long, but it's going to be 1 over 19, and you just got to substitute in these values. Okay, so let's do that. So we've got to put in minus. So first of all, we're going to put into here, we're going to put in 25. So it's going to be 25 to the power of 4 over 1,000. Here we're going to have 25 to the power of 3 over 30. Here we're going to have 5 times 25, and that's going to be squared. That's over 16. Here we're going to have 50 times 25. Okay, so that's the first bit done. That's substituting 25 in. Then we've got to do the exactly the same thing with 6. So there's going to be a minus, and there's going to be a 6 here, and that's going to be to the power of 4 divided by 1,000. Then it's going to be 6 to the power of 3 over 30. Then it's going to be 5 times 6 here to the power of 2, and that's over 16. And then finally we have 50 times 6. That's the end of that side, and then I'll just put a big square bracket in here to close it off. So this, I think, is everything we need to do. Now there's just a lot of calculator work here, so I have done a lot of it already, so I end up with 1 over 19 out here. Now when you do this part here, you end up with 1184 and 43 over 48. 43 over 48. Now you might want to do this in individual steps. Do another line in between here at least. Try not to just throw all this into your calculator. You may make an error here, but here we end up with minus, and we end up with 147327 all over 500. Okay, and that's it. When you do that, then 190, you subtract these two, multiply by 1 over 19, and you get 46.855. So that's the average value of this function between the closed interval, or within the closed interval 6 to 25. And that's it really for average value.